This is Project 3, video number 1. So we're asked to draw a box. Suppose to have side length L is equal to 1 meter. Supposed to have a slit in it, a double slit that is in the middle of one side of the box. The opposite side of the box is to serve as a screen. The double slit is to have a slit separation D, which is given by the user. It's an argument of the function. It's supposed to be illuminated by light, incoming light of wavelength lambda, specified by the user, and we're supposed to draw the lines corresponding to interference maxima. So let's play around with this a little bit and see if we can develop a plan. I think I'll call this the y direction. And so out to here is y max, which is L over 2, since we're starting from the center and going out to one side. So, and let's see what the maximum angle that we're going to have. I think I'm going to draw these lines. I guess I'm going to use m lambda is equal to d sine theta to find the theta for m is equal to 1. Well, that's m is equal to 0, though, straight ahead. I don't need to find that, just draw it. M is equal to 1, 2, etc., up to the point where I find that the angle is greater than the maximum angle, which will be, let's find the maximum angle. The maximum angle that could possibly hit the screen, theta max. Okay, this side is L. That side's L over 2, so we got tan theta max is equal to L over 2 divided by L. In other words, tan theta max is equal to 1/2. And I could use that to find theta max. Arctangent of 1/2. So that's going to come in handy. So I think what my plan is going to be is to use m lambda is equal to d sine theta to find theta. So m lambda over d, take the arc sine of that. I gotta watch out, if that's ever bigger than 1, then I take the arc sine, I'll just get an error. But let's see how we can deal with that. Okay, do this for each value of m up until theta gets to be bigger than theta max. I think what I want to do, so I don't like cause an error if I'm trying to take the arc sine of something bigger than 1, is I'll calculate the sine of theta for each m until the sine of theta gets to be bigger than sine of theta max. calc. So assuming I've already calculated what theta max is, this is just an evaluation. I think I'll call that. I think I'm almost ready to write the code outline, so I'll call that sine max sine equals sine of theta max. Alright, let's see if I'm ready for a code outline here. So I'm going to try it. Code outline. One, draw the box. 2, draw m equals 0 max. So the central max line, I think I'll call it. So in other words, I'll just draw the outline of the box and this line right here, the very center one. All right. Calculate max sine. Oops, so it's all one word, max sine. So using the formula that I calculated above, and then for calculate, I'm going to set m is equal to 1. Calculate the sine of theta for m equals 1. Alright. I think that'll pretty much do it, I think, for getting ready for calculating the m is equal to 1 line. And then I think I want to do a while loop. While max, yeah, let's I'll call it while sine theta is less than or equal to sine theta max. I want to calculate y for that particular one, and I guess we got to figure out how to calculate y. So for any n, I've got a value of the sine of theta, y over L is equal to the tangent of theta. So from our expression for the sine of theta that we got down here, I actually went as far as calculating theta, so go ahead and calculate what theta is. And then say y is equal to L times the tangent of theta. So calculate y using this formula. and then draw a line from this position right here. It's halfway over, so the position is 0.5 meters, comma 0. And then this position, yeah, I think in some sense I haven't been consistent because I want to use a coordinate system now. You know, just getting to the point where I'm being inconsistent. I want to call that x. I think I'll call that x prime and y prime. So I had a y coordinate system just extended over from there. That's just a one-dimensional coordinate system on the screen, but I got an x prime y prime coordinate system for all the positions in space. So I think I'm okay with consistency there. So draw a line from 0.5 meters, comma 0 to, now when the m is equal to 1 case, I got to draw it to this position and this position. So I'll do one at a time. I think I'll go to this position. So this is, I guess in space, my y prime, x prime is, it's 0.5 meters minus whatever y is. So I'm going to call it minus what I called y. This, by the way, is x prime, comma y prime. X prime, comma y prime. New set of coordinates. 0.5 meters minus whatever found for y, comma 1 meter. And draw a line to 0.5 meters plus y, comma 1 meter. Okay, let's make sure that makes sense. I calculate what y is. That's how far over I am to the right of this position. And then, weirdly enough, I got a coordinate system that I called y in a perpendicular direction. It's not ideal, but that's the way I got started, so I'll run with it. How far up I am, over to the right is 0.5, so it's 0.5 meters over to the right, minus whatever that one was, comma, and I'm 1 meter up. So this is my origin for my x prime y prime system. And then the other one was 0.5 meters plus whatever this value of y is, comma, and I'm also 1 meter up. So let's make sure I type that in right, because I got the calculate y using the formula above. Draw a line from x prime, comma y prime is 0.5 meters to 0 to 0.5 meters minus y, comma 1 meter. And from 0.5 meters, comma 0 to 0.5 meters plus y, comma 1 meter. Okay, that looks good. Then I think I'm ready to bump up m. So m is equal to the old value plus 1. And then calculate then end my while loop right there. So I just calculate the sine of theta for the new m, then I go up here and see if sine of theta is less than or equal to sine of theta max. So if it's less than, then I go in here and do it again, but each time m gets bumped up, since calculate the sine of theta gets bumped up, because using, I think I'll go sine theta equals m lambda over d. And that's what I'm using. That's what I was using here. Okay, so as I go through the loop, each time I calculate sine of theta to check to see if I'm going to, so I can use it to see if I'm going to go through the loop again, I'm using a bigger m, so sine of theta keeps getting bigger and bigger. Eventually it gets to be bigger than sine of theta max, and so I never draw that one. I calculate what sine of theta is, but I never draw the corresponding line for that one. And I think that's it. So I think that should do it for the whole code outline. I was obviously working this out as I went through it, so the notation isn't the best, but I think I'll go ahead and stick with that notation. So let's call that a wrap for project 3, video number 1, the pencil and paper part. Got a few formulas on there that are going to be useful, and then the main thing is the code outline.